Okay, welcome, folks. Good morning. Happy Friday. We are doing another installation of the Microsoft Networking Academy series. I'm your host, Brian Woodworth, Black Belt for Azure Networking and Network Security. I am joined today by our Azure DDoS Protection team. My guest works in the engineering side, Anupam Vij. He will be presenting a really nice run through and show you a lab demo of the Azure DDoS Protection offering and suite of tools. Just as a funny aside, I, of course, introduced this meeting as the Azure DDoS offering. In fact, we are not going to be watching Azure DDoS anyone. We are going to be watching Azure DDoS protection come into play. So some of my friends were quick to say, hey, are you going to be DOSing anyone this morning? And I'm sad to say that, unfortunately, this is all about protection and not about attacking. So my apologies to those of you that might think that we have some kind of attack platform. And in fact, we don't. This is all about protecting your infrastructure. So with that being said, I will turn the mic over to Anupam and welcome him. Good morning.
Thanks, Brian. Good morning, everyone. Anupam Vij, Product Manager for Azure DDoS Protection Services in Azure Networking. And today the agenda is I'll quickly do a run through of what the features are for the DDoS Protection Standard Service, how you can make use of your service, and what are the things that you need to kind of understand with respect to the product. Anytime you have any questions throughout the presentation, please leave the questions on the IM window, and my colleagues on the presentation, they will make sure that we respond back to the questions. With that, without further ado, so the quick thing I want to highlight with respect to the DDoS attack trends is what we are noticing is not only that the frequency of the DDoS attacks are increasing, but it's also the volume of the DDoS attacks that we see is increasing in the coming months. On a regular basis in Azure, we see and we mitigate around 200 to 400 attacks on a regular basis. And this is the industry trend as well. Now, the other interesting aspect is that the DDoS attacks are mostly used as a cyber smokescreen to mask other infiltration attacks. So they are just the entry point. And once the DDoS attacks are successful in a given environment, then comes the next set, which is the enumeration or the lateral movement. So that's where it's extremely important to understand that these DDoS attacks are on the rise and what protections Microsoft provides in terms to protect your applications in Azure against these attacks. We categorize the DDoS attacks in three different categories: volumetric attacks, the protocol attacks, and resource attacks. Resource
Anupam, we lost you. Can you hear me, Anupam? You went off mute. We lost audio. Are you back? Stand by, folks. Anupam still can't hear you.
Yeah, Brian, something is auto-muting me. So Teams is muting me automatically.
Interesting. I'm not sure if someone on the bridge is muting all that should not happen, but we can hear you now.
Okay.
So sorry about that. All right, let's keep going.
So in terms of the classification of the DDoS attack, the resource attacks essentially are the attacks that happens in the application, whereas the volumetric attacks and the protocol attacks are something where the exploits are actually used by either throwing a lot of volume of data on the network or exploiting the protocols. The reason I highlight this is because when we talk particularly about the DDoS protection standard, we provide protection at the volumetric and the protocol attack layers. Specifically for resource attack, the recommendation is to combine DDoS protection standard with the web application firewall because DDoS protection standard works at the packet header. We never inspect the packet payload. So the DDoS protection standard service is enabled on a virtual network. And once a service is enabled on a virtual network, it's extremely simple to provision. And I'll give a demo as well. But there is a simple toggle once you navigate to the virtual network to enable DDoS protection standard service. Once turned on, for every given public IP inside the virtual network, we provide automatic monitoring, which is 24/7 monitoring of all the incoming traffic. And we provide the network layer mitigation such that whenever we detect that there is a DDoS attack happening against your application, we will provide automatic mitigation against those attacks happening at the network layer. The DDoS service is designed into the global network such that we leverage the global scale of our Azure SDN, which is in 54 regions, to mitigate against the largest of the DDoS attacks that we have ever seen. As we mitigate against these DDoS attacks, what we also provide is the near real-time telemetry, such that you, as the customer of the service, you get to know if your resource is under attack. And whenever we are doing the attack mitigation, we also provide richer analytics such that you have deeper understanding of the type of attack that was incoming and the
Anupam, can you,
actions.
sorry to interrupt, can you share your screen again? I think that dropped, sorry.
I see.
Maybe you switch windows or just reshare. Sorry, folks. There you go. All right, can you back up just about, back up to the beginning of that slide again? Perfect.
So, all right. So I'll start over again on this slide then. So we enable DDoS protection standard on a virtual network. In terms of provisioning, it's extremely simple. On a virtual network, there is a subblade for DDoS, and all we need to do is to toggle it to DDoS standard. Once it's enabled, then for every given public IP inside the virtual network, we provide automatic monitoring, which is 24/7 monitoring against any traffic that's incoming that seems suspicious. And once we detect that there is a DDoS attack, then we will do the automatic mitigation. And the point to note is that the DDoS standard service is fully integrated into the Azure Global Network, or what we call as the software-defined network. We leverage the global scale of Azure networking when we are mitigating large-scale attacks. And as we are doing the attack mitigation, you'll get to see the near real-time telemetry and attack analytics, which highlights what resources are under attack in your environment, and also the actions that we are taking to mitigate those attacks, and richer analytics that will be useful for you to do the offline analysis. Most of the times, in fact, majority of the times, as we are mitigating the attack, we'll take care of the mitigation in the backend, and there's no need for you to reach out to Microsoft for support. But there are always corner case scenarios where you need some custom mitigation policies to be put in place. And towards that, we provide with DDoS standard service rapid response support, such that if you're under attack, you reach out to us within 15 minutes. Our engineering team will make sure that we are working with you to understand your custom requirements and putting in place the custom mitigation, thereby maintaining the availability and the performance of your application. We provide the SLA guarantee with the service, and we also provide the cost protection such that you don't have to worry about the unforeseen cost of DDoS attack in your environment. Simple provisioning. So DDoS protection standard is enabled on a virtual network. What you need to do is you need to create a plan. And once the plan is created, you navigate to the virtual network sublet. And by default, it's set to DDoS basic. All you need to do is to toggle it to standard. That's all that's required from a provisioning standpoint. We have implicitly made provisioning extremely simple such that you don't have to make any custom changes or in your application, or you don't have to make any changes in your environment to make use of the DDoS standard service. Now, the key aspect or the key feature for the DDoS protection standard service is the adaptive tuning. The moment you enable DDoS protection standard on your virtual network, automatically we enumerate all the public IPs that are inside that virtual network. And the example of the public IPs or the applications that are attached are like load balancer or application gateway or web application firewall. Now, for each public IP, we define 3 DDoS mitigation policies. One is for TCP, one is for TCP-SYN, and the third one is for UDP. One of the key attributes in each of these policies is at what point do we initiate DDoS mitigation? And the way we define that attribute is by running a proprietary machine learning algorithm in the backend to profile the network traffic that's incoming to your application during the peacetime. And once we build that profile, what we really understand is what does a network traffic volume look like for your application, say at 9 o'clock in Monday morning. And once we understand that, we'll start predicting that for every 15 minutes. And once we've built the profile of your application, then not only we will understand what does the network volume look like for Monday morning 9 a.m., but we'll understand how does that profile shift from hour to hour, day over day, week over week, month over month. And if we give it enough time, we'll also understand the seasonality. If I give an example, now let's say that there's an application, let's say it's a web service that's running inside the VNet on which we enable DDoS standard. That web application on a regular basis receives somewhere between 20,000 to 30,000 connections per second. We will learn that. And once we learn it, we'll keep some buffer and we'll set the policy threshold to 40,000 connections per second. Now, the moment that policy threshold is breached, let's say one fine day, the number of connections per second to that website suddenly increases to 80,000 connections per second. We'll call that as an anomaly. And at that point, we will initiate DDoS mitigation against that application. Now, just that we are initiating mitigation against the application doesn't mean that we're going to block the legitimate client connections. All it means is that at the point of mitigation, we'll start inspecting all the traffic that's incoming to the application. And if we find that the incoming traffic is malicious, we'll drop that traffic even before it reaches your application, again, thereby maintaining the availability and the performance of the application. Key examples to highlight on how we determine that the incoming traffic is malicious or not. We look for malformities in the packet header. If we find there are malformities in the packet header, we'll drop those flows. We'll look for things like invalid sequence number, checksums. If we identify those, we're going to drop those flows as well. We look for how frequently a given source is generating traffic against your application. And if we find that's above or below the norm, we're going to drop those connections as well. We also have a notion of source rate limiting. If a given client is generating more connections than we expect, then we're going to throttle those clients as well. Again, the essence is that anytime, and we make this determination in real time, if we make the determination that the traffic seems to be malicious, we're going to make sure that malicious traffic never reaches your application. All of this is done automatically in the backend. There is no user configuration that is required. Now, as we are doing the mitigation, if I further extend the example, so let's say that the resource is deployed in Singapore data center. The attack originates from Singapore originally. When we initiate mitigation, we'll start doing the mitigation in the Singapore data center. As the attack size grows, we have a concept of global mitigation, where we leverage the global scale of our Azure networking, such that when we announce global mitigation, if the traffic is incoming from US, we'll drop the bad traffic at US itself without backhauling that entire traffic all the way to Singapore. That way, we leverage global scale of our software-defined networking, such that now we can absorb and mitigate a lot more DDoS attacks at the same time, as well as huge volumetric DDoS attacks as well. Our global mitigation capacity is 25 plus terabits per second. And anytime we add a new data center or region, we continue to expand our mitigation capacity. This is a quick snapshot of the integration that we have done with the Azure Monitor. So the metrics or the policy thresholds that we define for the applications can be viewed through Azure Monitor. And this is what the snapshot reflects. So the top blue line over here shows the policy threshold that we have defined for, say, TCP protocol. And as we see, given its dynamically adjusted policy threshold, the threshold adjusts every 15 minutes, and that's why you're seeing those ebbs and flows. We also highlight if the application is under attack, we have metrics where you'll be able to see what application is under attack, what is the total volume of traffic that's incoming, what traffic are we dropping, and what traffic are we forwarding to the application. It's available for all the three protocols as well. And for each of these given metrics, you can configure the alerts. The alert could be an SMS notification, or it could be an email notification. And further, you can also integrate these metrics such that you can export them to your offline SIEM systems like Splunk, or you can do a further integration with the other products in Azure itself. We also provide attack analytics, and there are two features under attack analytics. One is the mitigation flow logs. Mitigation flow logs is 5-tuple information where while we are doing the attack mitigation, if you configure mitigation flow logs, you'll be able to export the sample data in real time of the traffic that we are forwarding, but also the traffic that we are dropping. And the information that we provide is the source IP, destination IP, source port, destination port. And if you are dropping, then the reason why we are dropping those flows. The real use case scenario for the mitigation flow logs is to integrate that into your offline SIEM systems in real time such that you can make decisions in real time if you need to. It's a great tool for you to do the correlation analysis in real time as the attack is being mitigated. The other feature with the attack analytics is the post-attack mitigation summary report. As the name suggests, once the attack is completed, or while the attack is ongoing, if it's a longer attack, then you'll be able to view the information like what are the key statistics involved in the attack? How many total packets are we seeing incoming? How many packets are we dropping? You'll also be able to view what kind of an attack are we mitigating? Is it a multi-vector attack? What protocols are involved if it's a multi-vector attack? Is it TCP? Is it UDP? Within TCP, what kind of attack vectors are we seeing? Along with the information like if we are dropping those packets, then why did we drop those packets? So the reason for the drop. In addition, we also provide information like what are the top sources from where the attack is originating? What are the top regions from where the attack is originating? Again, the whole idea is to make this information as actionable for you as the customer of DDoS standard as possible. On the rapid response, again, majority of the times as we are mitigating the attack, there is no reason for you to reach out to Microsoft for support, but there are always corner cases. In such instances, if you think that we need to put in some custom mitigation policies for your scenarios, then you can always reach out to us during the time of an attack. If you create a support ticket where you highlight the severity of the problem as critical and the problem type as being under attack, then our rapid response team will engage with you within 15 minutes, where we'll understand what your requirements are. And based on those scenarios, we'll make sure that we provide you white glove support service and we put the custom mitigation policies in place. Again, the whole idea, the entire idea here is the DDoS standard service is ensuring that during the time of DDoS attack, your application availability and the performance is guaranteed. DDoS attacks are all relative, right? So given the idea of a DDoS attack is to take your backend infrastructure offline, it doesn't necessarily have to be a 1 terabit per second of an attack to do that. A targeted attack can be of a much lesser volume, and that's where DDoS standard ensures that the mitigation kicks in and it's sensitive to the traffic volume of your application. Now, specifically, if you are running web workloads in your environment, then against the layer 7 or the application layer attacks, our recommendation is to deploy a web application firewall. It could be a web application firewall from Azure, which is the App Gateway WAF, or it could be a web application firewall from the marketplace. Once you deploy the web application firewall, the public IP of the web application firewall is injected into the VNet. Now, even a web application firewall can be taken offline if there is a volumetric attack against that web application firewall. So the recommendation is to enable DDoS protection standard on the virtual network of the WAF. Now, here's a side-by-side comparison with DDoS Protection Basic, which is the infrastructure protection that's always enabled, always on by default. So anytime you deploy a resource in Azure, Azure provides infrastructure level protection against the DDoS attack for those resources. DDoS protection standard is that you enable on the virtual network to get application specific protection against the volumetric and protocol attacks. The key differences is in terms of the availability guarantee with DDoS protection standard, we provide that availability guarantee that during the time of DDoS attack, your application or resource will not go down. And the reason we guarantee that is because the DDoS mitigation policies that we tune are tuned for your application's traffic volume versus with DDoS Basic, the mitigation policies that are tuned, they are tuned for the Azure region traffic volume. In addition, as discussed, with DDoS standard, if your application goes under mitigation, then you get the near real-time visibility into the attack metrics and the analytic, as well as you get the SLA and the cost protection. Talking a bit more on the cost protection, what it entails is, let's say that you have deployed a virtual machine scale set, and the initial deployment of that virtual machine scale set was 10 VMs. As your application was under attack, if that virtual machine scale set grows out or scales out from 10 VMs to 100 VMs, if you're onboarded to DDoS standard, you won't have to worry about the cost of those scaled out VMs. You'll get the cost credit back. The same is also applicable for data egress, just in case during the time of DDoS attack, and this is something that we are noticing right now when it's NTP amplification attacks specifically, that if there's a huge data egress or the bandwidth bill that you're noticing, then if you are onboarded to DDoS standard, the cost protection will ensure that you get the cost credit back for the data egress charges that you may have incurred. DDoS standard is also integrated with Azure Security Center, such that if you have a virtual network in which there's a public IP, say for an application gateway or a load balancer that's not protected with DDoS standard, then we provide recommendations in Azure Security Center. So you'll see those as critical recommendations in ASC. Before we move into the demo, one thing I would like to highlight with respect to the pricing, and more details are also available on our public portal, is that there are two components involved. One is the fixed fee. So before you create or before you enable DDoS standard in your environment, you have to create a DDoS protection plan. The DDoS protection plan is created in a given subscription, but it works across the entire tenant. So let's suppose that in a given tenant, there are 10 subscriptions. When you create the DDoS plan, you link the plan to subscription one. That subscription one will get a monthly recurring bill of $3,000 per month. Now, you can go to any of your other 9 subscriptions and select the virtual network in any of those subscriptions and link to the same plan. So you only need to create the plan once in a given tenant, which works across all the subscriptions in that tenant. And then there's a variable fee that's involved, where on any given virtual network where DDoS standard is enabled, there is a graduated billing meter which bills against the data egress to the internet. Any data which is within the VNet or within the Azure data center, that's not counted for. So at this time, what I would do is I'll switch to my browser and I'll quickly give you a demo. So in order to enable DDoS standard, the first thing that you need to do is you need to create a top level resource, which is a DDoS plan. So if I search here, so DDoS protection plan, All you need to do here is click create. So you give it a name, select a particular subscription, select a resource group, and that's pretty much it. So once you hit create, and I already have a plan created in my environment, so I'll show you how it looks like. But plan is a top level resource. The whole idea is that once you create a plan, then any virtual network that you link to that plan will show up over here. It becomes easier in terms of managing that plan and understanding like, what are the virtual networks that you are protecting in your environment. Again, the plan is created in a given subscription, but it works across your entire tenant. So as long as you give the right permission, which is also documented in our documentation, you will be able to link any virtual network against all your subscriptions in your given tenant to the same plan. Now, once you have created the plan, then you have to navigate to a given virtual network to enable DDoS protection standard. So in this case, I'm going to navigate to a virtual network here. On the virtual network, we see a DDoS protection sublet. By default, it's set to basic. All you need to do is toggle it to standard, select the plan from the drop-down, click save, and that's pretty much it. So provisioning, extremely simple. You don't have to worry about deploying additional keys. You don't have to worry about configuring anything specific. All you need to do is to toggle it. And then we will enumerate all the public IPs and we'll start defining the mitigation policies. So now I'll navigate to Azure Monitor to highlight some of the key metrics that we talked about in the previous slides. So I'm navigating to Azure Monitor metric. In the resource, I'm going to select the resource as the public IP. So even though we enable DDoS on a virtual network, the protection is applied on the public IPs. So in this case, I'm going to select this public IP here. And now what we see are the set of metrics that are available for DDoS protection standard. Now, the first metric I would like to show you are the policy triggers that we have defined for this public IP. So we define 3 policy triggers, which is inbound SYN packets. This is for TCP SYN to trigger DDoS mitigation. Likewise, we have inbound TCP to trigger DDoS mitigation metric, as well as we have inbound UDP to trigger DDoS mitigation metric. So if we take a look at the inbound TCP SYN packets to trigger DDoS mitigation, what we see here is that the metric value right now, or the threshold, is defined as 10,000 connections per second. Now, the reason we have defined is this threshold is because we understand by reviewing the traffic profile on a regular basis that this application doesn't receive much traffic. In addition, what we also take care or we inspect when we are doing that machine learning algorithm profiling is how many virtual machines are behind this public IP. If there are limited number of virtual machines behind a public IP, we'll make sure that the policy thresholds are tuned accordingly versus if you have like say 100 of virtual machines behind the same public IP. So the point I want to emphasize again here is that DDoS attacks are relative. And that's where it's essential that the policy triggers that are defined for the application are sensitive to the environment or to the application that you have deployed and the amount of traffic that application is receiving on a regular basis. So likewise, for the other metrics as well, we define these policy thresholds. So in case of TCP, the policy threshold is defined as 100,000 connections per second. And for UDP as well, we have defined a different policy threshold. So only when these policy thresholds are breached is when we initiate DDoS mitigation. So now let me show you another demo. We have partnered with a company called Keysight. The product name is Breaking Point Cloud, such that if you're onboarded to DDoS protection standard, then you can use this dashboard to simulate DDoS traffic against your application, such that you don't have to wait for an actual DDoS attack to happen to document your compliance, to train your security teams, to understand how your application would react under a DDoS attack, and to make sure that you have a full understanding of how the attack metrics and analytics would look like when there's an actual attack without having to wait for an attack to happen. So I'm going to start generating the test. And in my environment, given the policy threshold for TCP SYN was set to 10,000, so even 100,000 connection per second is going to look like a DDoS attack. So in this case, I'm generating a TCP SYN flood against the application. And within few seconds, you'll see as the attack is generated, we'll start seeing those metrics showing up in real time as well. Now, as the attack is generated against the application, one of the key metrics to highlight here is under DDoS attack or not. So if there's no attack on an application, then the metric value will always be 0. But whenever there is an attack that we are mitigating, the metric value will become 1. And this is one metric where I specifically request all our customers or recommend all our customers to create an alert such that anytime there's an attack that we mitigate, the metric value becomes 1. You get an email notification or SMS notification that your resources are under attack. So in the interest of the time, I generated some graphic before hopping onto this call. So we see that the metric value anytime I generated the attack actually became 1. And as we are mitigating the attack, you'll also see that in near real time, we start showing the attack telemetry through Azure Monitor as well. So what I will do is I'll highlight, for instance, TCP packets. So we have inbound TCP packets DDoS, packets drop DDoS, and packets forwarded DDoS. So inbound TCP packets is the total volume of packet that was incoming when we were generating the attack. So in this case, we see that the attack volume was around 100,000 packets that we were generating. And let's take a look at how many packets we were dropping as we were mitigating the traffic. So what we see is it's like almost 1-to-1. So we were dropping exactly 100,000 connections per second when we were doing the mitigation, which highlights that we were doing a damn good job at the mitigation. Essentially, what we were doing in this case, given we are generating a TCP SYN attack, for every incoming connection, we started challenging those connections. So we were doing a SYN cookie auth challenge. And then given these are all rogue connections generated through a botnet, there was no response on that challenge. And given there was no response, we dropped those connections immediately. So if we take a look here at the packets forwarded, you see that there's hardly any packet forwarded because there's no real traffic coming into the application at that time. Now, these are the near real-time metrics. You can export these metrics to an offline SIEM systems as well using the available API and the CLI. But what we also provide is the attack analytics. So the way we configure the attack analytics is through Azure Monitor. You navigate to diagnostic settings. You navigate to the resource group where the resource is deployed. And then the resource type, again, would be the public IP. So in this case, I've already configured the attack analytics. So let's take a look. So you click on the resource type, which is a public IP. If there's no configuration, you click on Add Diagnostic Setting. In this case, I'll just highlight by editing it. In order to receive the mitigation flow logs, which are the near real-time flow logs or the sample logs or the traffic that we are forwarding as well as the traffic that we are dropping, all you need to do is to select the mitigation flow logs. For mitigation reports, which is the post-attack summary report, all you need to do is to select the mitigation reports, set the number of retention days, and then you can select where do you want to export these logs and reports to. You can export it to the storage account, you can export it to the log analytics, or you can stream it to an event hub. The real use case for the mitigation flow logs is to ideally stream it to an event hub such that you can see line by line how those logs coming in. For mitigation reports, as the name suggests, the real use case is to either put it into a storage account or to export it to the log analytics so that you can build some visualizations and dashboards around it. Once you have selected that, just hit save, and that's all that's required from the provisioning standpoint. Now, for the demo purposes, what I have created here is a log analytics workspace in which we are pumping in the data. So let's take a look at the workspace summary here. We change the time duration to last 4 hours. So this is a sample dashboard that I have created for the mitigation flow logs. Now what we see here is the IP that's under attack. So this is a resource that's in Azure that's being attacked right now. We see a distribution of the traffic flows. So total number of flows that we received and the total number of flows that we dropped. We are also highlighting what were the top sources from where the attack traffic was generated. So the computers, the IPs here are the top sources, which are essentially like the botnets or the malicious sources and the clients. Then in addition, we are highlighting the distribution of the packets observed, the packets that were forwarded to the service, and the packets that were dropped. And then we also highlight that what was the action taken while we were dropping those packets. Now, in real world environment, what we actually see is that, for instance, in the cases of like Mirai attack or Reaper attack, there would be multiple protocols that will be involved. So in those cases, you'll see that there are like multiple actions that we are taking. And that would be very helpful to kind of understand why and what were the top reasons that we were dropping those packets. Likewise, we also highlight that in your application, what were the ports that were under attack? For instance, if you have exposed multiple ports and if all the ports were under attack, you'll see that information here. So this is the mitigation flow logs. Now, what we also have is the post-attack mitigation report. So in this case, let's take a look here. So the things that we are highlighting in the post-attack mitigation report is more detailed statistics of the total volume of attack that we have seen or the traffic that was incoming during the duration of the attack, as well as the volume of the traffic that we were dropping. Again, the information on the protocols, but the nuances here is also that we are highlighting from which countries and from which continents the attack originated, as well as the AS number of the routers from which the attack originated, along with the drop reasons. Now, the other thing I'd like to show here is the sample of the alert that is generated when your resource is under attack. And this is again configured through Azure Monitor. So the first highlights that when the resource was under attack, we kind of provide the information that when was the resource under attack, what was the resource name, which in this case is the public IP information, and we highlight the reason. Now, if the attack mitigation is resolved, so the attack happened, say, for a duration of 10 minutes, and then after that, we remove the IP from mitigation, then we also resolve the alert. So we don't keep the alert open forever. So you'll get another notification saying that the alert was resolved. Now, usually there are like a lot of, so security is a shared responsibility, particularly when it comes to securing your infrastructure into your virtual network. So towards that, we have published the best practices reference architecture documentation, which is available online. And what we have highlighted here are like, what are the minimum best practices that you need to put in place to ensure that your applications are resilient against DDoS attacks? And it's all about defense in depth approach. So you have to make sure that you have applied controls applicable to your scenarios in your application, as well as in your overall infrastructure. In the same documentation, we also highlight that what are the key reference architecture recommendation in terms of positioning and deploying DDoS protection standard with other network security products like Azure Firewall, as well as Web Application Firewall. This is one of the best practice recommended architecture slide that we have that kind of we highlight and recommend to all of our customers, putting all our network security components together, where essentially the recommendation is that anytime you deploy a resource that needs to communicate to the public internet, you deploy those resources into a hub virtual network. And then all the backend services, you deploy those in the spoke VNets, such that those backend services, if they have to communicate to the public internet, they go over the hub virtual network using a VNet peering and then reach out to the public internet. The other thing to highlight here is that anytime you're exposing your application to the public internet, which means that your application has a public IP attached and listening on at least one port, then it becomes absolutely mandatory, or it's very important that you protect your application against DDoS attacks. Because DDoS attacks, as we highlighted, as we looked into, they are all relative and they are very common. These are just high level, again, kind of samples or examples of the type of attack mitigations that we see on a very regular basis that we have also published information about on our website as well. And so NTP reflection, DNS reflection, ping flood, these are all the attacks at layer 3 and layer 4 that we mitigate against. So this is the demo that we just gave. Again, the DDoS protection planning. If you're onboarded to DDoS protection standard, you have enabled that for your virtual network, then you don't have to wait for an actual attack to happen to make sure that you document compliance or train your security teams or understand how your application behave. The best practice here is that you should actually test your assumptions on a regular basis. And that's where this tool will help you to do that. With that, I will just close it with a couple of thoughts here. First of all, in terms of enabling or security controls for your applications in Azure, we kind of divided under application protection and then micro-segmentation. So all these services that are highlighted, DDoS, WAF, firewall, NSG, and then VNet integration, they are all complementary. If you think from a zero trust approach or defense in depth, from micro-segmentation, you need to make sure that you are creating virtual networks to limit or segment the traffic that you want for your application within a VNet. If you want further segmentation, we recommend to go for like creating multiple subnets to further limit the traffic. Make sure that you are using NSGs to block ports that are not necessary. And then if you are exposing your hub VNet to the public internet, we recommend that you deploy an Azure firewall such that it allows the inbound layer 3 and layer 4 traffic, and then outbound, it also protects layer 3 to layer 7 traffic and also provides the logging capabilities. Specifically, if you're deploying web application workload in your environment, a recommendation is to deploy a web application firewall. And for any application that is receiving traffic from the internet, we strongly recommend to enable DDoS protection standard. With that, would love to take the questions.
So thanks, Anupam. That was fantastic. Thanks for the demo as well. The breaking point tool, I think, is really valuable and a really unique offering to the service. It's really great. A couple of questions that came up in the chat that may not have gotten vetted. I want to make sure that they get a little airtime here. One, Steve Defano, I think, brought up an interesting point, which is, do we have or maybe have an idea about like a global dashboard where I could say see all of my endpoints in a map or a heat map and understand my traffic level protections and what's going on there globally? I thought that was a pretty good question.
For the IPs that are being protected by DDoS standard.
Precisely, right.
That's right. And so something, yes, it's on our roadmap, something that we are considering right now. But even today, like we provide the PowerShell scripts and the CLIs such that you can actually gather all that information and view it. So if you want to view, like, what are your IPs that you're protecting right now, that information you can collect. but with respect to kind of a heat map or visualization, it's not there, something in our backlog.
Okay, great, thanks. Vikas asks, can we use the same DDoS plan for all VNets within a tenant, or I have to follow hub and spoke model?
It can be all VNets. So these are two different questions, right? Uh, can you use the same plan across all your VNets in your tenant? The answer is yes. Should you follow the hub and the spoke model? I would say the general recommendation is definitely yes, but it's like heavily biased on the scenarios.
Okay. Paresh asks, do we have a threshold where we kick out an application for being too expensive to protect?
No.
All right. Krishna asks, how about a PDF report? Is there a way that that's a native offering where, you know, you could say print a white sheet out for a review or a battle plan, something like that?
Something that we are reviewing internally. Is
Cool.
that yeah?
Yeah, he was just wondering if that's the native tool set now, but it looks like it's under review. That's great. I selfishly have a question. Can you talk to the audience and myself a little bit about the machine learning component that's doing all the smarts behind it? So as a two-part question, one, what are your personal thoughts about training and letting that model warm up to where it's going to be, you know, providing excellent fidelity on good put and bad put? And two, you know, is that engine something that you built specifically for this service? Is it something that Microsoft is using for other purposes? Talk to us about that a little bit, if you can.
Okay. So yeah, so the way the machine learning model works is that from the time you enable DDoS standard on the VNet up to a period of 2 weeks, we learn the normal traffic volume that's incoming to the application to define the threshold. The machine learning model is a predictive model. So we look into the past data, and then we try to predict the next 1 minute of data, next 2 minutes of data, and so forth, such that once we have kind of defined, we have trained the model good enough, which is usually takes like up to 2 weeks, then we can predict every next minute of data and then adjust the policy thresholds dynamically. The time period to adjust the policy threshold is 15 minutes right now because we kind of think that that's a right time period. Now, the other thing I want to highlight is just because the model takes up to 2 weeks to train doesn't mean that the policy thresholds are not kind of tweaked from the time the DDoS protection standard is enabled up to 2 weeks. By which I mean is that we also look at the number of virtual machines that are behind that public IP. So now let's say that, and these are like all hypothetical numbers to just kind of use as an example. So let's say that the DDoS protection basic for TCP protocol, the threshold is at 100, let's say 300,000 packets per second. You enable DDoS protection standard on the virtual IP, and behind that virtual IP, there are like, let's say 10 machines. Then within few hours, what we will do is that we'll start inspecting all that information, and then we'll lower that policy threshold from like 300,000 packets per second to something like 100,000 packets per second, because now we have taken in consideration the number of virtual machines that are behind that public IP. Now, from that time period onwards, you continue to learn what is the normal traffic profile for that application. And then we continue to either lower it or we start increasing that policy threshold based on what we are seeing as a normal peacetime traffic incoming to that IP. Does that answer the question?
Yeah, it's great. So there's other questions that are coming in on chat. Instead of having me, just kind of run point there, I think folks, don't be shy. Take yourselves off mute and just step in and ask Anupam whatever's on your mind here. And do keep in mind we have friends, partners, customers, and all Microsoft employees together. So it's like we're at a booth at a conference. So that being said, please, this is a great chance to talk to some of the minds behind Azure DDoS.
So one question that came in from Tash, like how does this apply to PaaS services that has no VNet integration and has public endpoints? And so there are like a couple of models in the PaaS services as well, right? So first I would like to touch on like the VNet integration itself. So some services actually inject their IPs into the VNet. So these are like VNet injected services. For instance, HD Insight or Redis Cache or even Application Gateway. These services are covered under DDoS protection standard. Now, there are other PaaS services like storage or SQL, which uses the service endpoint. Now, these services do not require DDoS protection, standard protection, because the whole idea of service endpoints is to kind of eliminate those public IPs uh, to access those services from the VNet. And then there are other PaaS services where like they cannot be injected into the VNet, like web services, which is the web apps or the app service environment. Now, for these services today, our recommendation is to deploy a web application firewall, then protect the VNet of the web application firewall with DDoS standard.
Hey, Krishna here. Can you guys hear me?
Yeah.
So I just came out of a discussion with my customer. I'm working on Rogers, so which is a telco here. So what they are struggling to do is they buy Azure Security Center and then Azure DDoS. So what they're asking me is, you guys are selling all the security products. Why cannot be there's one SKU where I buy with a single like model without me spending multiple different line items and things like that? And the second question is, with Azure DDoS, they really want to know in real time which assets in Azure are protected with a single viewpoint, like we do in AAC. I know it's a loaded question, but my customer paying, I like to pay X amount of dollars for my security on Azure. So it seems to be you guys are splitting them into so smaller chunks. I just don't know which one to pick up, which one not.
Thanks, Krishna. You kind of asked like a bunch of questions in there, but I think what I really picked up is so many security products out there. We have Security Center as well.
Yes.
Can we have a better integration story together?
Exactly. That's
right.
That's my customers. It came from the CSO, right? So he said, I like your products, but it seems to be split into so many small pieces. I just don't know which one to buy, which one not to buy.
Good feedback in terms of the integration, and I think what we need to do is to kind of articulate it the way it is right now and to understand the scenarios and then come up with a proposal, something that we can work on offline, I think.
Yeah, anyway, Monday you're meeting them anyway, so that's a question that come up anyway. Thanks for that.
Yeah.
Folks, any other questions? We have until the top of the hour.
I have a question, if you guys can hear me.
Yeah.
So I'd like to, it may be not quite related around DDoS, but the one slide that you showed like the best practices, defense in depth, all the different layers, all that good stuff. I'd like to kind of see the networking team and security team collaborate for some best practices and recommendations around the use of ASGs as well, and how that factors in, especially in a large scale environment.
Absolutely. In fact, there is and we can share the YouTube link of the video where we have created a session that we presented at Ignite, which is building enterprise grade DMZ in Azure, where we combine or club all these network security services like ASG, NSG, service tag, service endpoints, VNet injection, firewall, and DDoS together to kind of highlight how these services all kind of come up together and how you can actually use all these services and controls in Azure to secure your infrastructure based on certain key scenarios. And the three key scenarios is, one is the traffic that's incoming from the internet. The other scenario is how do you connect to the PaaS services to your VNet. And then the third scenario is like, how do you use NSGs and ASGs for micro-segmentation, and then further connect your VNet on-prem environment. So we'll share that information with you.
Okay, thank you.
Yeah, Anupam, what might be some keywords for folks to search on YouTube to find that? Would you know? Just maybe NSGs, ASGs, or anything else?
It would be building enterprise-grade DMZ in Azure.
Perfect. Thank you. All right. Well, unless there's any other questions, as always, I want to thank my audience. I want to thank our participants, and I really want to thank Anupam for availing himself to teach us all about the service and going through the time to get the slides and the demo together. Anupam, thank you. It's been incredibly valuable and informative for me, and I hope for others as well. Guys, next week we have another great new, well, standard DDoS isn't exactly new, but we have a new service coming out, Azure Front Door, and we'll be learning all about that next week. The short story there is that that is a global layer 7 application traffic steering engine that provides you with application acceleration and protection. And we will have the Azure Front Door experts on to tell you all about the capabilities of that platform. So that's going to be super exciting. Hope to see you guys next week. Have a safe and happy weekend, and thanks all for joining. I will get the recordings for last session with F5 and this session posted to the YouTube channel hopefully by mid next week. I put the link to our YouTube channel in the chat. Please do feel free to subscribe. That's where all of these recordings will go for future reference. And thanks again. Take care.
Thank you.